Hey y'all, it's me, Miss B. Today we're talking about double angle formulas. So here are the double angle formulas written right here. And the first thing we're going to do is we are going to verify the identities. And we're actually going to use the sum and difference formulas. Really just the sum formulas, but it's the ones that we learned in 5.4. Okay, so we're going to do three of them together, and I'm going to save the last one for you guys to do on your own, just as a good little practice for verifying identities. Okay, so here's how this one's going to go. As sine of 2 theta, I'm going to work from the left to the right. So sine of 2 theta, I can write as sine of theta plus theta. Now, if I were to call this alpha and this beta, I can use the sum of sine formula. So this can be written as sine of theta cosine of theta plus, same sign, cosine theta sine theta. All right, let's keep sine in front since we have that. So we have sine of theta cosine theta plus sine theta cosine theta. All we did was switch those two out. And so then we have two sine theta cosine thetas, so that gives me 2 sine theta cosine theta, which is my identity. Okay, easy as that. Go ahead and just take a look at this next one for a few seconds before we start it. Okay, so we're going to write this as tangent of theta plus theta again. It is a little weird writing it as tangent of theta plus theta. Then we're going to write the sum formula for tangent. So we've got tangent of theta plus tangent of theta over 1 minus tangent theta tangent theta. Okay, I know that we could easily combine steps, but we don't want to do that. We need to show that each step is equal to each other. And 2 tangent theta over 1 minus tangent squared theta is not equal to tangent theta plus tangent theta. Or I'm sorry, tangent theta plus theta. So we have to show this second step here. Then we can combine like terms. So we get 2 tangent theta over 1 minus tangent times tangent gives us tangent squared theta. Okay, which is our identity. All right, this next one you'd probably be able to do on your own. So I'm going to give you a couple seconds to get started on it. So we have cosine of theta plus theta. Then we can rewrite as cosine theta minus opposite sign for cosine, sine theta, sine theta. And so we get cosine times cosine is cosine squared, and sine times sine is sine squared, which is our identity. And then finally, this last one I'm going to leave for you guys to do on your own. And if you don't get to the final thing, that's okay. I just asked you to try. So I'm leaving that last one for you. Okay, so let's look at some actual problems. Okay, so it says if sine of theta is 5 over 13 and theta lies in the second quadrant, find the exact value of the following. So we're gonna need to draw a picture because we don't just need sine, we also need cosine and tangent to solve all three of these. So let's go ahead and draw a picture up here. We're in the second quadrant, so draw our picture accordingly. Okay, so here, just draw an angle, drop down that side so you have a right triangle. Here's theta. Sine is 5/13, making this side over here -12 using the Pythagorean triple. Let's go ahead and write out what sine theta, cosine theta, and tangent theta are. So sine theta is 5/13, it's given. Cosine is adjacent over hypotenuse, so -12/13. And then tangent is opposite over hypotenuse, so 5/-12 or -5/12. All right, so let's use our formula. So sine of 2 theta is equal to, let's change the colors here, I'm getting a little bored. So sine of 2 theta is equal to 2 sine theta cosine theta. So now it's just a plug and chug. All I have to do is plug in. So sine is equal to 5/13 and cosine is equal to -12/13. If I put this over 1, I multiply straight across. So 2 times 5 times -12 gives me -120. 13 times 13 is 169. Why is this writing so weird? Okay, so I do not believe that simplifies any further. All right, cosine of 2 theta. So we have a few formulas we can use. Let's actually look and see. I usually do cosine squared minus sine squared. It's the one I remember the most. But it really doesn't matter which one you use. So cosine squared theta is -12/13 is cosine of theta squared minus sine, which is 5/13 squared. So then we get, want to simplify, so -12 squared is 144, 13 squared is 169, 5 squared is 25, and again 169. 144 minus 25 is 119/169, keeping that denominator the same. So that does not simplify any further either. Okay, and then let's do, gonna leave you a second to do tangent on your own. All right, so tangent of 2 theta is 2 tangent theta over 1 minus tangent squared theta. So I have 2 tangent of theta is equal to -5/12 over 1 minus -5/12 squared. So simplify. So 2 times 5 is -10/12 over 1 minus 25/144. So we get, simplify again, negative 10 over 12 all over 119 over 144. And then to simplify further, negative 10 over 12 times 144 over 119. This cancels, we get 12 and nothing. And so we get negative 120 over 119. Now, if you look, remember that tangent is sine over cosine, so we can check that final answer. And sine is 120 over 169. Cosine is 119 over 169. So then tangent is definitely negative 120 over 119. Okay. So then let's go ahead and work on finding these exact values here. So these ones are the ones we're working backwards. So this is saying that theta is equal to 15, and it's using that tangent of 2 theta formula. So then if I plug theta in, I get tangent of 2 times 15, or tangent of 30, which is radical 3 over 3. All right, go ahead and try this next one on your own. Okay, so if I were to write this out, I know that cosine of 120 is 60 plus 60. So I'm using those first quadrant angles. So then this is cosine of 2 times 60. So then I can do cosine squared of 60 minus sine squared of 60. And so then cosine at 60 is 1/2 squared. Sine at 60 is radical 3 over 2 squared. So we get 1 over 4 minus 3 over 4. I get that by squaring both the top and the bottom. Let me write that out. So if I have, let's say, radical 5 over 2 squared, that's the same thing as radical 5 squared over 2 squared. Okay, so that's how we get that. And then 1 minus 3 is negative 2 over 4, or negative 1/2. All right. One last problem here. So I have sine theta minus cosine theta squared, and I want to get to the right side, which is 1 minus sine of 2 theta. Let's go ahead and work from the right. Or I'm sorry, let's work from the left here. So I'm going to take sine of theta minus cosine theta times sine of theta minus cosine theta and multiply it out. So I get sine squared theta minus sine theta cosine theta. I'm not going to draw out my arrows. I'm just doing it the FOIL way. Minus cosine theta sine theta minus plus cosine squared theta. This right here becomes 2 sine theta cosine theta. And this right here, using our identity, is 2 sine of 2 theta. So I get sine squared theta minus sine of 2 theta plus cosine squared theta. I know that this adds up to be 1 minus sine of 2 theta, which is what we wanted, and we're done. All right, we're saving this last one for class. Go ahead and give this one and this one a try before class. That's all.